Welcome back, secondary educators. Let's take a look at the normal distribution. We'll work through an old IB standard level question on the normal distribution. We'll talk a little bit about what that is and how it works and why we care. So the normal distribution is this thing that looks like so. Oh, that's hideous. Oh, that is just hideous. I'm going to get crushed in the comments section. Normal distribution. You have some quantity that has a mean and some standard deviation, and what we find is that adding a standard deviation, adding 2 standard deviations, adding 3 standard deviations, or subtracting standard deviations roughly breaks down in the following way. Within 1 standard deviation of the mean, you've got about 68% of all of the data points. Within 2 standard deviations of the mean, you've got roughly 95% of all data points. And then within 3 standard deviations of the mean, you've got 99% of all data points within 3 standard deviations of the mean. Those are all the numbers we remember, and students come away with the 68, 95, 99 rule, and they get it, they understand it, they tolerate it. But what does this actually do? What does it say? Well, the normal distribution is a probability distribution, right? So the mean is the most common outcome in the set of data. And then as you move away from the mean, outcomes are less common in a predictable way. There are very few points in the data set that are high above the mean, and there are very few points in the data set that are far below the mean. This is why we talk about heights of humans as being normally distributed. Most people are about average. There are very few very tall people. There are very few very small people. Most human beings are about average. There are lots of quantities we can think about that are normally distributed. Where most people are about average, that's the most expected outcome. And then about average, sure, lots of people are about average, and then the further away you move from average, the more exceptional that is on one end or the other in roughly equal proportions. So this is how we talk about the curve to give students a conceptual understanding of what is happening. Beyond the mathematics of what is happening, we have to be able to explain what the phenomenon is and why certain data points, certain data sets are not expected to be normal. If you don't expect most of the data to be around average, then it's probably not normally distributed. That's the way this goes. So let's talk about an old IB question. A company buys 44% of its stock of bolts from manufacturer A and the rest from manufacturer B. The diameters of the bolts follow a normal distribution. Standard deviation is 0.16 millimeters. And we know manufacturer A has a mean diameter of 1.56 millimeters, and 24.2% of the bolts produced by manufacturer B are less than 1.52 millimeters. So we're supposed to find the mean diameter of the bolts produced by manufacturer B. Well, how do we do that? Well, we know that manufacturer B has 24.2% of their bolts less than 1.52 millimeters. Well, what does that mean? Here's manufacturer B's normal curve. Here's 1.52 millimeters. This is 24.2% of the bolts. So what we do is we find the z-score that corresponds to 1.52. The z-score represents the number of standard deviations below the mean that 1.52 millimeters is. And your calculator can figure that out. On a Texas Instruments calculator, you would ask for the inverse norm of 0.242. And you'd get that this z-score is negative 0.699888360 whatever. That's the z-score. Well, what is that? That's the number of standard deviations below the mean that this is. Well, how do you compute a z-score? You take that number is the measurement minus the mean over the standard deviation. Well, what's the standard deviation? 0.16. And that's a linear equation, and we can solve. So the mean for manufacturer B is 1.63 millimeters. And that makes sense. If only 24% of the bolts are below 1.52 millimeters, then the mean has to be bigger than 1.52 millimeters, and so it is. That's a reasonable answer. So now we'll use the normal distribution. A bolt is chosen at random from the company's stock. We want to show that the probability that the diameter is less than 1.52 millimeters is this number. Well, how do we do that? Well, we know that the company buys 44% of its stock from manufacturer A, so there's a 44% chance that it's coming from manufacturer A, and there's a 56% chance that it's coming from manufacturer B. Well, we already know that for manufacturer B, the probability of being less than 1.52 millimeters is this number right here. And we know that the probability of coming from, well, that's an interesting question. What's the probability that manufacturer A is going to be less than 1.52 millimeters? We've got some distribution for manufacturer A, and manufacturer A has a mean of 1.56 millimeters. So here's 1.52 millimeters. What's that area? What's that probability? Well, we know what the standard deviation is, so we know what the z-score that corresponds to this is, and we can ask our calculator what that probability is. You should make sure that you know how to ask your calculator what that probability is. For Texas Instruments calculators with which I am familiar, it's a normal CDF function. And we give some large value on the far left end, and then 1.52, and then the mean, and the standard deviation. And those four parameters tell us what that probability is going to be. This turns out to be 0.312, and so we have confirmed it. So then we ask the conditional probability question. If the diameter is found to be less than 1.52 millimeters, what's the probability that the bolt was produced by manufacturer B? Well, we already know that the probability that the bolt came from manufacturer B is this, and we know the probability that the bolt was found to be less than 1.52 millimeters is this, and that happens to be 0.434. It's a conditional probability question. We find the probability that the bolt came from B and was less than 1.52, and then we put that over the probability that the bolt was less than 1.52 millimeters, and we have a conditional probability. Then the last question asks us about expected profit. So we know that manufacturer B makes 8,000 bolts in a day, and it makes I'll let you read for a moment. You got to read. So what's expected value? Well, the expected value we know that the probabilities and the profits play together. So we figure out the probability that we're between 1.52 millimeters and 1.83 millimeters, and that can be found to be 0.242. Then we have bolts that are less than 1.52 millimeters, and we can figure out that probability also. Golly gee, I'm going to get crushed in the comments. That's the 0.650, that's 0.242, and then there are very few bolts over 1.83, that's like so. So how do we find expected value? We take each probability and multiply by what happens if that bolt comes to pass. Each probability times what happens if that bolt comes to pass. Each probability times what happens if that bolt comes to pass. This is the expected value of the expected profit or loss on one bolt, but we're going to make 8,000, and whatever that number is the expected profit for manufacturer B. We multiply probabilities by what happens if those probabilities happen, and that's how we do expected value. This is one way people use the normal curve. It has been used with teenagers. I hope that someday you get to teach this stuff to teenagers. Looking forward to seeing you when we gather.